we have been doing derivatives. We've learned a shortcut, but we've only learned shortcuts that apply if it is x to a power, or we also learned the derivative of e to the x is what?
E to the x.
Yes, derivative of e to the x is still e to the x.
E to the x. EA Sports. It's in the game.
So, anytime we had things being multiplied or divided, we had to rewrite it first. But that's not always an option. So we need to learn how we can do these derivatives if we truly have things being multiplied or divided.
This feels so one-on-one. Like it
I
already
know.
feels one-on-one, but it feels even more now.
So, the first is a product rule. And are you guys okay if I just tell you the rule, or do you want me to derive it for you?
No, that's fine.
Okay. Alright, so this is, you have the derivative of two functions being multiplied. You do the first times the derivative of the second plus the second times the derivative of the first. In other words, you do one derivative at a time. Another way to write it would be to say f times g prime plus g times f prime. We do one derivative at a time, the other function stays the same.
Okay. That's so much
That's
nicer.
Yeah, that's a nicer way of writing it.
I looked at the first way and I was really confused.
Okay, so if I put this question on your quiz last week, you could have done it, but you would have multiplied it out first, right?
Yeah.
Let's try to do the product rule on it. So, the product rule says, we have two things being multiplied, okay? So we do the derivative of one at a time. Technically, it doesn't matter which. So which one do you want to do first? The first or the second?
First.
Okay, so derivative of the first one would be what?
Oh.
Oh, is that not what you meant?
I meant the first.
So keep the first the
I meant
same?
f times g prime.
Okay,
Is that not what you meant?
so that stays the same. So the first function didn't change. Times, what's the derivative of the second one?
6x minus 5.
Okay. Plus,
Negative 12x squared.
derivative of the first one. And the second one stayed the same. All right. Again, it doesn't matter. We're multiplying and adding. Does order matter in either of those cases?
No.
No. So it doesn't matter which one you write first. You just have to do one derivative at a time. The other one stays the same. Now, I would not give this for my final answer. I would expect you to then multiply it out. So if we FOIL the first, we get 6x minus 5 minus 24x to the fourth. It's 20x cubed. Distribute the negative 12 through the second one.
Okay, you got the same symbol. Go.
All right, then we are trying to combine any like terms.
Negative 60x to the fourth. Right? Plus 80x cubed. Minus 24x squared. Plus 6x minus 5. I was doing that and I was like, this seems not right.
Okay. Could we have gotten that if we just multiplied out the original and then did the derivative?
Yeah.
Yes. But there are cases where we can't. Now, in general, it's up to you if it's a case where you could multiply it out. So on this type of problem, it would be up to you if you wanted to do the product rule or multiply it out. But I'm going to show you our next example, there would only be one option for how to solve it.
Mhm.
Are there any questions on this one?
Number 3 doesn't look so nice.
Okay. So if I look at this one, x times e to the x can we actually multiply those and just have x to a power? No, so there is no way we could have done this derivative last week. But we can do the product rule here. So if we have two things being multiplied, it's not as simple as you're just doing each derivative. We have to take each of them separately. And you do the first one, which is x, times the derivative of the second. Derivative of e to the x is
E to
E
the
to the
X.
X. Dope.
plus derivative of the first one, what's the derivative of x?
1.
Times the second, which was
E to the X.
e to the x. So we get x e to the x plus e to the x for our derivative.
That's so silly. You basically just got more.
It did. So polynomials get smaller as you do the derivatives, but that's not the case with everything.
But he's decide they want to get bigger.
This one got more complicated. All right,
What the is?
find the nth derivative. I want to see if we can come up with a pattern. We just found the first derivative. Let's do the second one.
Wait, let me guess. There's more e to the x.
What?
I bet you're on to
I
something.
bet
Okay.
I bet there's 3.
We know that we have to do each of these derivatives, right? We have to do the derivative of each term. So the first term, what's the derivative of x e to the x?
1 E to the X.
X e to the x.
Oh, what? Hang on, what's happening?
If you want to do the derivative
It's
of
just e to the x.
no,
No. We
It's-
have to expand it.
we have to do the product rule.
Yeah.
What am I doing?
But it equals.
Oh, you break it apart like the first
Yes.
one again. Okay,
Yeah.
I understand now.
So derivative of the first one, derivative of x, or
X.
we've been doing the second one first, haven't we? So the first times
See,
derivative of the second, derivative of e to the x is e to the x,
I was doing that. I was just not using the right words to say what I was doing.
plus the first one,
1
derivative of the first one is 1,
E to-
times the second one. Okay, so we did the product rule for that term, plus we have this e to the x. What's the derivative of e to the x?
e to the x. I am cooking, Grayson. I see it.
So we get x e to the x plus e to the x plus e to the x would be
2 E to the X.
Oh, well,
I'm not
I
cooking
didn't
anymore.
combine them. But
I mean, I cooked, but I'm not cooking in the brain.
what do you think the third derivative would be?
X E to the X
X e
plus
to the x,
3 E to the X.
Mm-hmm. So the
You just add an E to the X. It's
nth
crazy.
derivative would still have the x e to the x plus n.
X e to the x plus e to or n e to the x.
Mm-hmm.
Nths get me so confused. We did it one time in Algebra 1 and it just keeps coming back to haunt me.
It's just saying, can we find a formula for whatever derivative I might ask you for? So if I ask for the sixth derivative, it would be x e to the x plus 6 e to the x.
I just cannot.
Okay, let's do some more. Alright, if I want this derivative,
Oh, I'm cooking.
would this be one where you would probably multiply it out or do the product rule?
Product rule.
Could you FOIL it if you chose to?
Yeah.
Yep, absolutely. It is your choice. But since I'm teaching product rule today, I definitely want to practice it product rule way. So, product rule says you do one derivative at a time. The first one stays the same. Times, what is the derivative of the second one? So remember, a square root is a 1/2. So what's the derivative of x?
1 plus x to the negative
1 plus 1/2 X.
1/2. Oh,
To the
I
negative
forgot
1/2.
the 1/2. Gosh dang it, man.
It always makes me feel good. So good when I catch something that Carson doesn't. I don't
Dude.
know why. I'm just
Flux.
spiteful like that.
Hanging on my downfall is crazy.
For real.
Derivative of the first term. What's the derivative of 3x plus 1?
3.
Times the second term. We're not going to change it. X plus x to the 1/2. So if I wanted to finish this, would I have to FOIL now?
Mm-hmm.
Yeah. Would it have been faster to just FOIL at the beginning? Probably.
Maybe.
But I'm teaching product rule. We're not just going to start with the ugly problems. So
1 times negative a half. No, if you multiply and add them, so you get a half again.
Yeah.
yeah. So with 3x times 1 is 3x. When I multiply these, we get 3 halves. Add your exponents. So 1 plus negative 1 half is 1 half. Plus 1 plus 1 half x to the negative 1 half.
I don't even know how to order this. Like,
Plus 3x plus 3x to the 1 half.
do you have to order it in number order?
No, we can put it in any order. So 3x plus 3x is 6x. Okay, 3 halves x to the 1 half plus 3x to the 1 half. So 3 is like 6 over 2 plus 3 over 2 is 9 over 2.
Wait, which one are you doing? Oh,
Okay, so that one probably would have been faster to FOIL first, but this way we got to practice our product rule.
okay. Oh, you made that back into I see, I understand. I put a square root.
And then we factor.
Yeah. And then we just
I
keep
see
going
the
till we
lines.
die. I see the lines.
Alright.
I want someone to walk in here so bad, and that's like, I see the lines. I can see the lines.
Yep, they're on the ceiling.
Is this one okay?
Oh yeah.
We
I
just
am
start-
going to
Oh, I see them.
skip examples 4 and 5 for now. They are in the video you're watching tomorrow. I want to go ahead and do the quotient rule. So we've seen both while I'm here. So, quotient rule. If you have two things being divided, so it's g times the derivative of f minus f times the derivative of g over g squared. Another way to remember it, you're probably going to hear me say this a lot. Low, so g is the function on the bottom, so it's the low function. D high, so the low one times the derivative of the high one, minus
High,
high d low
How did you know that?
over low squared.
Please never say this out loud to me again. Just say it confusing. Say the first one.
low D high minus high D low over low squared.
I will probably say that. So, it's kind of like the product rule on the top, except there's a minus, so now order does matter. So you have to do the derivative of the top one first. So it's the bottom times the derivative of the top, minus top times derivative of the bottom, over the bottom squared.
How do we know what is F and what is G?
F is the top, G is the bottom.
Okay.
Alright, so if I ask you to do this derivative, yes, we could write this with by simplifying it, but I'm trying to teach a quotient rule, so I'm going to do the quotient rule way. So, our derivative is low, the bottom, which is
2x squared.
times derivative of the top. What's the derivative of the top?
20x.
Or
20x
20x.
minus 6.
Minus high, the top, d low. What is the derivative of the bottom?
4x. All over that bottom bad boy squared.
Yes. Over the bottom squared.
If you square, you add, you multiply.
Alright, so if I start multiplying this out, 40x to the 5th minus 12x squared. Can I distribute the negative and my 4x on this
Yes.
one? Minus 20x to the 5th. 24x squared. Minus 28x. Over
4x to the 4th.
combining like terms. So we get 20x to the fifth plus 12x squared minus 28x over 4x to the fourth. Can we reduce anything?
Take out an X.
And
Up to.
4.
4.
So we get 5x to the fourth plus 3x minus 7 over x cubed.
Wowza.
Whoa. Oh, so. Do you care if in this case we did the to the negatives of the x? Okay.
The Y? The what? The who?
So,
Well, if I'd given you the same problem last week, you would have wrote this as 5 halves x squared minus 3x to the negative 1
Plus 7 halves X squared.
x to the negative 2. And if you did this derivative, that would have taken you to 5x plus 3x to the negative 2 minus 7x to the negative 3, right?
yeah.
Okay, let's look. If you take 5x to the fourth over x cubed, that's 5x. 3x over x cubed is 3x to the negative 2. Minus 7 over x cubed is 7x to the negative 3. They're equivalent.
Yeah.
Is the first way a lot faster? Absolutely.
Yeah.
In general, if you can simplify first, that's going to be faster. But if you did the whole quotient rule, you get an equivalent answer.
You just sprung that on us, and I was really confused.
All right, so if I gave you this one, could I simplify this problem first?
No.
No, because I have more than one term on the bottom. So this one I would have no choice but to do the quotient rule. So quotient rule is low, so the bottom, d high, derivative of the top is
2X plus 1.
minus high, d low, derivative of the bottom
3X squared.
2x or yeah, 3x squared.
over low squared. All right. So if I multiply out the top, I get 2x to the fourth plus x cubed plus 12x plus 6 minus over here 3x to the 4 I am not going to FOIL on the bottom.
I heard you did before. Oh.
It's not wrong if you do. I'm just not going to. It's nicer to leave it factored in case things would cancel out later on. But it's not going to make a difference on this one. So combine like terms.
Negative X to the 4th minus 2X cubed. No, yes. Plus 6X squared plus 12X plus 6 over X cubed plus 6 squared.
All right. Questions on that one? So final problem of the day.
Today. Oh, we got through this quick.
I know. There's 4 examples I'm not doing. They are in tomorrow's video. All right, if I wanted the derivative of this, is there any way to write it without a quotient?
Nah.
No. So it's low, the bottom, d high. What is the derivative of the top?
0. So it's 0 plus.
Minus high.
Minus
D low, what's the derivative of the bottom?
2X.
Over low squared. So that first term drops, so we have negative 2x over x squared plus 1 squared.
Yeah.
Oh, you just stopped there.
Yep. That's all we have to do.
Okay.
Alright, so if you have x's multiplied or divided, you either have to combine them first or do the product or quotient rule. So today we're going to do the handout, tomorrow you'll finish the video and start the book problems. And then we'll do a work day Wednesday to kind of catch up when I'm back.
I'm kinda happy with those, with that work day now.